Thank you very much, and welcome to this talk about writing VS Code extensions for fun and profit. I'm hoping at the end of this talk that you will know a little bit about how you might use VS Code extensions to improve your development workflow when working with C++ code. First, I'd like to share a little bit about myself and my background. I have a background in electronics engineering and process control. I started out doing mostly embedded C code on microcontrollers, but for the last 10 plus years, I've been working mostly with C++. I've been doing mostly like frameworks and supporting work for other developers. And recently I've gone more over to do like different kinds of tooling because I find that quite interesting. Currently I work for Siemens Gamesa, where I'm doing some wind turbine control software. And if anybody wants to reach out to me, you can always reach me at my email address. But enough about me, let's look at the contents. So the first question you might have is, why bring this up at a C++ conference at all? So I'll touch a bit on that. Next thing I'll show is IDE extensions and how they can help with like development workflow. I'll answer a question, why VS Code? Why that editor? Why not other ones? And then we're going to go into a bit of a live coding exercise where we're going to do a kind of hello world in the VS Code extension world. And then once we have that, we can kind of spring into some more advanced thing, some easy to do quality of life improvements. The idea is it can kind of get your heads started to see, how can I maybe use this to improve my my workflow. And in the end here, I'd like to do a little case study, something that we actually did, where we tried to replace a legacy IDE we had with a more modern IDE like VS Code. So with that, let's go to the first topic here, like why bring this up at a C++ conference at all? Because this has nothing to do with C++. And this is kind of correct, because if you're looking for a talk about the new C++ features, this is not the talk for you. This is more talk about tooling and how you can improve like development workflow, but there is a focus on how you can do it in C++ because there are some pain points that are a bit specific to C++. So the thing is, a lot of time that we spend is actually also spent on non-coding tasks. It's not only sitting with the keyboard and typing code that we spend our time on. We spend a lot of time configuring builds. Which component do I want to build out of our software? How do I want to build it? Should it be debug? Should it be release? And all of these things, where should they be located and all those things. In particular also debugging, where do I find debugging system symbols and all of these things. That can also take quite a bit of time. We have various fairly tedious refactoring tasks where we would like to automate some of that. And also sometimes you need to put in a lot of boilerplate code. It depends very much on how your process is in your particular company or when you're coding. But some of these things is definitely something that also takes from your time. And these things are often done, or they're at least helped by various automation tools, which we build as part of our daily lives. So tooling is very important. It helps us to improve developer satisfaction because they help us to deliver code faster. And I saw there was a quite recent keynote at the CPP now by Anastasia Kazakova, I hope I pronounced that correctly, called C++ Painkillers for C++ Developers. And this talk is very much about these C++ painkillers, because an IDE as such is just a tool that we use to make it easier to do our code. And these extensions can also help to make our life easier and make our developers, make them able to focus on their main task, which is thinking about the problem at hand and how they can solve it in code. And I think like nothing really takes the joy out of coding and working as when you have something that's either very slow or very tedious. You want that quick feedback. It needs to be fast to compile your stuff, getting debugging up and running. All of this should just work. Otherwise, it just takes some of the joy out of the work. So that's kind of why this kind of makes sense for a C++ conference, I find, because it is tooling, and we do use a lot of tools in C++. So now we have the next question there, why VSCode? And well, VSCode has been on the top of like a desired IDE in a recent Stack Overflow poll. It's quite popular with many developers, as you see on this graph here, at least. And I think that comes from a few things. It's relatively lightweight, I would say. So that's nice. And I think the main thing about it is that it's extremely configurable. Like there's already exists a lot of extensions that you can use to add different kinds of functionality to VSCode. You can tailor it very much to whichever workflow you are. Is it doing Python, is it doing Rust, is it doing C++? You can kind of tailor it to it. And that is really powerful, these extensions. And that's what I want to show a bit, how you can use extensions to further customize VSCode to follow your workflow and help you get your stuff done. And I said, yeah, using these extensions, VSCode, which basically is just an editor, can be made into something I would call an IDE. Also, it has quite a familiar interface for multiple programming languages. As I said, it can be tailored to all these different programming languages, but the look and feel of the editor will be the same. So that's quite nice. One thing that definitely comes into play when you want to customize is if the extension API is easy to approach. And for VSCode, I would say it's very well documented. Also, there's a GitHub repository where they have a lot of different extension samples. You can just take those and use that as kind of a boilerplate code to start your extension, or learn a lot from that. So that is very, very nice. It's very easy to get started, as you're also going to see very soon. Are some of the takeaways from this talk? It's not necessarily specific to VSCode. I'm hoping that other editors, that you can do something fairly similar to this. I'm hoping with this talk as well that I can maybe open your eyes a bit to trying to customize your editors, because that can bring a lot of productivity gains in your daily life. Okay, so next question. Why write extensions for VSCode? Now, I touched a bit on it already, but I'm going to bring a list here. What's in it for me? First thing is that you can integrate your IDE with custom automation tools. In your company, on your daily life, you probably made a lot of little tools to like quality of life improvements, and integrating those with the IDE just give them even more value than they already have, because you can do everything with just like one hotkey or something like this. You can go as far as to actually pretty much replace legacy IDEs if you have to. It's something that we done, which worked quite well actually. And also you can automate very repetitive tasks by using these extensions. So that's some of the benefits that you can have, but there are some other benefits which are not as apparent as you might think. And that is that you can learn another programming language and a whole nother ecosystem. In this case, it's TypeScript, and it's the Node.js package manager. And it's always very healthy for programmers to know all kinds of different programming languages. I was going around a bit and think I would like to learn another language, but I don't really know how to get started. This is a great way to get started. And TypeScript is actually quite a nice language to program in once you get started. Yeah. And last but not least, it's quite fun to do this. I like you get something quite quickly when you write these extensions. You get some feedback, you get some graphical interfaces that you can click and point, which is quite enjoyable to use, and you get a very fast feedback loop on whether your integration is working. And one thing is, these extensions, it doesn't need to be huge, complicated tool integrations. You can start with the very low-hanging fruit first. It can be just essentially calling a script with some different parameters just by using a hotkey in VSCode. And then you can kind of build on top of that and integrate more and more tightly with the editor. Okay, and with that, I think we should actually already get started with the first Hello World extension. And the Visual Studio website here actually gives you a nice little website here that says how do we get started with this. So first you need to install Node.js and Git. I've already done that, so I don't need to. And then you need to run these commands. So we're just gonna see if I can zoom in a bit here. So I'll copy these commands here, and let's go to a terminal here. Copy again, enter, and this will install something called a Yeoman code generator or whatever it is. It basically creates the scaffolding for a new VS Code extension. You can choose some different types of extensions here, but usually I say new extension, and I want to use TypeScript because TypeScript is kind of like a type-safe version of JavaScript, and coming from C++, I know the value of type safety. So that's definitely what we want. We'll just call it Hello World, give it an identifier and a description. My extension doesn't really matter. In this case, I don't want to initialize a Git repository, so we'll say no. Then we can bundle it. We don't want to do that. All of these things are a bit more advanced. We're not going to get into that here. We want to use npm as a package manager. Just press enter. And what it has done now is that it's created all of these files, which is essentially the whole Hello World of a VS Code extension. You can also see that npm has automatically installed all dependencies that you need to develop this. So 266 packages has gotten installed. So that's fantastic. On the other hand, 266 packages have been installed, which is also a little bit scary, but I guess that's just the JavaScript and Node.js world we're entering here. In the end here, it asks you, do you want to open your new folder with Visual Studio Code? We say yes. It's going to open. And what you'll see here is that we have all of these files here, and two of the most important ones. One here is the package.json. Just going to put this screen a bit bigger. So package.json is the manifest of the package here. You got the name, display name, which version of VS Code this is compatible with, where the source is, and one of the most important parts is this contribute section, where here this extension contribute one command. So this is an array of commands. It's called hello world, and it's got the title hello world. And this means that every time this extension is loaded, you have access to a new command in VS Code called hello world. And whenever it's executed, it will call this command, and that this ID here kind of ties in to the extension source code, which is here in extension.ts. So if you open this one, you can see there is a function called activate, which is called every time our extension is activated. And in this one, you see we register a new command called hello world, and that will execute the lambda here. See if we can just get a bit more space. Doesn't look like it. There we go. So we'll execute this lambda here and just show us an information message. Let's just change a bit. Hello world from Meeting CPP. And this should all be ready to run. So all we need to do is press F5 to launch the extension in a debugger. It's going to translate TypeScript into JavaScript and run the extension here. And what it has done now is that it has spawned a new VS Code instance called the extension development host, which is running the extension that we just made now. So what you can see now is that if I press F1 to run commands, you can see hello world has gotten added. And if I press enter now, we get the pop-up hello world from Meeting CPP. So we're off and running. It's very fast. It's very easy to do. You can even put breakpoints if you want. I just put a breakpoint here before we show the information message. If I try now to run the command again, we'll enter the debugger and we can inspect variables and everything that we expect to be able to do. So yes, that is essentially Hello World from a VSCode extension. Very easy to get started. But this doesn't really help us very much because it doesn't really do anything. So let's do something a bit more interesting. Well, just to recap, install Node.js, generate the scaffolding, answer the questions asked, open the extension, and press F5 to start an extension debugging session. Then you're off running with a custom extension. Yeah, but next thing, let's try to make an actual useful command. But that means we need to learn a new language, which is TypeScript. And in my opinion, to learn a new language, you need two things. You need a fun project to work on. Otherwise, you'll never have the motivation to go through with it. Writing an extension is a fun project, so that's covered. Next thing, you need code examples and a mentor. And it can be a little bit tricky to find a TypeScript mentor in a C++ shop, but we can use ChatGPT. It can actually be both of these things. It can give you code examples because it has deep knowledge about TypeScript. And it can also be a mentor because you can ask it question about why do you do this, why do you do that. Also, it has knowledge about the VSCode API. As I said, documentation is quite well done on the VSCode API. So ChatGPT has scraped all that. It could be another kind of chatbot, but it has scraped all of this information so it knows how to use it, and you can ask it to elaborate on solutions. Of course, all the advice I come with here with ChatGPT comes with all the caveats against ChatGPT. It will hallucinate sometimes, especially when things get a bit more advanced. But for the simple things, which is what you will do when you just start learning a new language, it actually does quite well. It usually gets things pretty right in the first time, and it's definitely better to be able to talk to that one than to just sit alone learning a new language. I've definitely used it a lot to learn TypeScript. So we're going to try to do that, and we're going to try to make an actually useful command. And it's a so-called text editor command, and I prefer calling it kind of an advanced search and replace because you do changes to the text buffer that you have. And what we want to do here is fairly simple. We want to autocomplete include paths. So imagine we have some C code here. We've got some libraries here, but we can't remember exactly where these libraries are located. So we want an extension that can just autocomplete these, something like this. This is just an example to show what's possible here. So let's get on with a live demo. So what we'll do is let's just fire up ChatGPT, and then I say, better be nice to it. It's going to take over the world soon. Okay. I want to make a VSCode extension. Looks for the something like this. The good thing about ChatGPT is also you don't really need to type everything exactly. It can kind of suss out what it is you're trying to do and come with a solution that will be pretty close to what it is that you're doing. I'm going to go with this one. Let's just see how it goes. Yeah, so it actually takes it everywhere from scratch, how you start the things. So that's good. And then it comes first here with some TypeScript code. Now, you don't need to understand all of this, but you can kind of suss out what's going on. So we register a new command called find include. Then we find the active text editor. If there's none, we return. We find which line we're at, and then we use a regex to find an include. If there's an include match, we find if there's workspace folders. Then we find a header file, and we find the relative path, and we insert the path. That looks pretty good. Find header file. It looks for some stuff. It's a directory. Yeah, it scans through some things, try to find the file. Insert path. We use the editor to edit the text, and we insert the relative path to this position. That looks kind of right. Let's just try to copy that. Usually you would try to read a bit more what's actually going on here, but we don't really have time for that. We just copy and paste. So that was the first part. Let's look at what else it says. Oh yeah, we need to update this package manifest because we've got a new command now. Let's just update that as well. Let's go to package.json. We've got this. Well, the command has actually changed its name, so now it's called find include, and it's called find include path. Let's see what happens here. I'll just restart the extension. Here we go. And for this, I have made a little example project just as a demo. In this example project, we have one application. It's got a CPP file, and then it's got 1, 2, 3 libraries with some header files here. And what we would like to see now is that when I run the command we just made, it should look for this include file, find this name here, and search our workspace here and put in the full include path. So let's just see if it works. Let's call something include, find include path. That doesn't look quite right. Well, there we go. It does something, at least. I think there might be some race condition in this code. Just ask it once more to see if it can do it better. There's a few different ways. I've tried this a few times, and it comes up with different solutions every time. Some of them works, some of them don't. But you can see kind of what I'm getting at, that you get all of this TypeScript written out here that's specific to the problem you're trying to solve, and you learn a lot from this text here. Let's go back to this one, and let's just retry it now, see if it's doing better. Should have had our new one here. Let's see if that worked better. Find include price. No, not really. But it's doing something at least. And we would probably need to tailor this code a little bit. But some of the stuff is kind of okay. It's probably this wait search for header files that is not really working that well. We try to put a breakpoint in this one and see what actually happens. We search, let's see the found file. It actually finds the right file. It looks like it's this insert relative path that is not working that well. Yeah, exactly what's happening here, I'm not entirely sure, but you do get a lot of the boilerplate code kind of made for you with ChatGPT, and you can learn a lot from it. So I hope you kind of get the idea of this, that you can use these commands to do kind of search and replace in your text document. And in this example, it was a fairly simple thing we tried to do. Just do a search and replace and find a file, but you can do anything that you would like to do. You can read files and take text from there and insert into your document. You can open databases, connect to servers, and basically do anything you like. Again, if that is something that could be valuable for you, if you have a database and you want to also complete some C++ code based on contents from that database, you can do it. directly from your VSCode, directly from VSCode. Yeah. So let's just find the where did we go? Yeah, it was ChatGPT. So some success with ChatGPT, not complete success. I've had varying degrees of success, but generally it's quite a nice help when you're starting out a new language from scratch, because you can ask and get responses immediately, and it can help you do some code sometimes. Yes, so that is like what I call an advanced search and replace. That's one of the things you can do. It's fairly easy to get done, and it can actually help quite a lot on some tasks that you have while coding. So wasn't that fun? I think it was quite fun. We kind of got there, not quite, but at least we were pretty close. Yeah. So the next part is a case study. So what we had in our company, we were kind of stuck with this legacy IDE, and we had this in-house built system, as you sometimes do with very old code. And we wanted to replace this IDE because the integration between the two was very poor. There was essentially not really a lot of integration. Debugging was effectively non-existing. You could debug, but it was so tedious to set up that nobody used it. And my feeling is that there's a lot of developers that just make do with what's easily available. If it's not easy to set up, they'll simply not use it. If there's no debugger, we'll just use couts and live with that. If there's no address sanitizer, okay, but I'll just try to do it the hard way. So it's very easy to have your tools very close and very accessible and easy to use. Otherwise, your developers will simply not use them, and you will lose so much productivity in that way. So what we did was that we started playing a little bit around with customizing VSCode. And the way you do it is through two things in general. So we have this thing called task configurations and this thing called launch configurations. And task configurations are the way that you usually integrate external tools with VSCode. I'm just going to show how that works. Let's just find an example that makes sense here. Yes, here. So this is a version of a tasks.json file here from VSCode. It has got, there's a new task, that's an array of tasks. One of them is called run tests. And all it does is it spawns a shell and runs this command. So that can be a task called run tests. It just runs this, this test. Quite simple, but it can be very powerful if your tools are like command line based. So that's one way of integrating tools into VSCode. The next thing are these are the launch configurations. And launch configurations are usually done to, well, launch the programs you want, and especially launch them with a debugger attached. I'm just going to show quickly how that looks. It is also a JSON file. So you give a name to your launch configuration. In this case, it's to launch with the Visual Studio debugger, and you give which program you want to launch, and you can also give like simple search paths and stuff like that. So in this case, if we run the CPP launch Windows from with the debug configuration from within VSCode, we will launch app 1 and we'll find symbols in these two directories. It's just a quick crash course in out-of-the-box VSCode customization. And by using these two, we got pretty far, but we were still fairly limited. Because as you can see, these task and launch configurations are pretty static. We need to have a hard-coded path for the executable and for where to find the two shared, like the symbol files, and also the arguments you need to give to the in the tasks. The arguments you need to give to the command you need to run are also static. and it doesn't scale that well. Like it's well suited for if you have just like one or two components or executables in your software, but we were having several hundreds, and that just simply didn't scale. On top of that, we also wanted all these quality of life improvements, like the stuff I just showed, and more advanced version of that. So we thought, well, let's just go the extension way and improve on this. We also wanted to have like one-click builds of the current component, like as we were browsing around in the source code. We said, okay, I just want to build my component right now, just with one click or one hotkey. And the same thing with debugging. We wanted that to be very accessible as well. And many of you think, yeah, that's obvious. Everybody should have that. But if you look at legacy code, it's not always as easy as this. In our case, we needed to auto detect what is the current component. We needed to find where are the shared library paths. Again, we had a custom build system. It did not necessarily put things where you expected, and sometimes it changed a bit. So we needed to find them. We were doing remote debugging as well, so we needed to automatically upload the component we had just built and all of its dependencies to the target. And in the end, we needed to also launch the debugger on that remote target. So it gets quite a few things that you need to do. So the question then, did we succeed in doing this? Yes, we did. Otherwise, I wouldn't be standing here. Next thing, was it hard to do? No, it was not. It was actually a lot of fun. I get a lot of joy out of doing these tools and seeing how productivity can be increased. And I get feedback from developers, oh, this is great, we can do things much faster now, but maybe you can tweak this and this so this works better. That's really something that I like doing. So for me, at least, it was very fun. Yes, so I'm going to go a bit more into how we can do it. And the first thing that is possible to do is that we want to resolve, you saw in launch.json and task.json, it was very static, but you can actually resolve these files and paths dynamically. And again, let's go for a demo. And here I'm not going to use ChatGPT anymore. So let's find, I've cheated on the other hand. And made an extension already. So let's just, it is this one, and let's just look at the package.json. You can see it's the same thing. We have some different commands here. And the thing about these commands is that they don't interact with the editor. All they do is that they try to resolve paths and they return a string. And these strings, let's look at the launch. Let's look at the tasks JSON, for example. We got a task here called C++ build active executable that will run the GCC compiler and give it some different arguments. And these are just hard coded, but these ones will actually run these different commands from my extensions. So it will get the number of the files that we need to compile. It will find what should the executable be named. If there's any additional compile arguments, it also gets it. Sets the current working directory and all of these things. And if you go back to the manifest here, you can see that is exactly these commands here. And again, that we have the same in the extension here. So get files to compile here. It will get the active the directory which the currently open file is in, and then it will just join that directory and return a list of all the CPP files that are in that directory. Now, I think it might be a bit clearer if I just show you exactly what's going on. So I'll build and run the extension here, and I will open a example project here. And in this example project, we have one executable here with 2 source files. We have another executable with just 1, and we have a library down here. So if I open any CPP file in this executable, then I can run a task called build active executable that will call all of these functions in my extension, which will resolve all of the paths. And in turn, we will call, as you see down here, we'll call GCC. And this is the expanded, the string that was returned from the function that was called in my extension. So you can see it found out, okay, this file is located in my executable 1. So I want to build all of the CPP files that are in this one. And by the way, I want to call it my executable 1 because that's the name of this, this directory here. Yes, and we can do the same thing with the library here. Let's go to that and let's try to build it. And you can see here it changed a bit because here we also said that it's shared and it's now called libmylibrary1.so. And the way that's done is, well, fairly simple. We've got some business logic here in our extension that checks if the active file directory includes the string library. We're probably building a library, so we call it something else. This is very, very crude, but it just shows you that you can kind of tailor the business logic in this way. You could have some way more clever things going on than what we have here. But for this example, it kind of works. It gives the right names. So that's how we can get VSCode to build all of these things. I'd like to show you how we can also invoke the debugger. So let's just go here. Unfortunately, I have not made this extension able to compile this my executable 2 because that depends on my library 1. And I had limited time to make this. But I've built this now, my executable 2. That depends on libmylibrary2. So in order to execute the debugger on this one, it needs to know where this library is. So we need to resolve it. So let's just see if the debugging works. Let's put a breakpoint here. We have a breakpoint already in libmylibrary. And if we go to the debugger tab here, we have here launch current executable. We'll run that and hopefully we will get, yeah. So we hit our breakpoint here and you can see it has loaded the right library here. Let's see if we can, yeah. So the breakpoint in the library is also hit. So all the symbols are red and everything is nice. And you might be wondering how we do that. And we do it from this launch.json. And what happens is somewhat the same as in the tasks. Like we find what's the executable path, what's the executable name, we give the current working directory, and then we have this thing that sets the LD library path for the executable. And we just run a command here. And this command will search for whatever shared objects that this my executable 2 needs. And how do we do that? Let's just look at the code. It is a very brute force way of doing it. But again, an example of how you can automate things. We get the path of the executable, and then we just run readelf, which can give us a list of all the needed libraries for this executable. Then we do some regex to extract all the libraries. And then we just do a find files, a bit like we did with the include paths. We just try to find all the libraries underneath our workspace, and that is essentially how it works. We can just try to put a breakpoint and see. Let's go to this one and invoke the debugger, and that has now run this command, and we see the list of candidates here. Should be able to see. Yeah, let's just scroll over. Yeah, it found this one. You can also see the output from the elf here. We get this text, and all needed libs is libmylibrary. We've got libfcc ++. That's usually just included, so it's only this one we really need to find. And then in the end, continue. We have all the search paths here, which just includes the directory where my library 1 is in. That's going to be given to the debugger as the LD library path, and we're happy. We can invoke the debugger. So that's a very crude way of doing it, but it works in many cases. Sometimes you can do something more clever. By all means, do. But it's a way that also works. This is also you can do many different things, and it's fairly easy to do actually. It's also what I'm trying to get at here. Yes, so that's how you can customize these launch JSON and tasks JSON. Granted, this is a fairly trivial case here. It is not flexible. If you get something a bit more advanced, then it's not quite good enough. Like if you have more advanced cases, VSCode gives you something called task providers and something called debug configuration providers, which are way more flexible in the way that you can give arguments to a debugger and how you can invoke tasks. But it is way beyond the scope of this talk to do that. But that's something you can look at if you really want to get a bit more into this. And you can see here we directly invoked the GNU, the GCC build tool, but it could also be just invoking whatever custom build tool you have. And that is kind of what we'll get to as the next thing, because that's about how we can integrate legacy build system into our workflow and into VSCode and make it nice to work with. And for that, I will introduce TerraBuild, which is a build system I made kind of for this presentation, because I can't actually show you how we did it because it's all of this proprietary stuff. So I made this build system that kind of tries to emulate how some legacy custom build system might work, a build system that has not gotten integrated into any editor already. So it's got a configuration that's based on some JSON, and it's command line based. So being command line based helps a lot if you want to integrate tools. So that helps. So again, we go directly on to the next demo, and we'll do it in the same way. I have cheated a bit and made an extension already. But before we start with this, I'll just show you a bit of how TerraBuild works. It's a tiny little Python script which parses this JSON file here. You can define which build tools you want to use. In this case, we download LLVM and build it, and then we use that to compile our binaries. So whatever TerraBuild needs to find where to find these compilers here. There's some packages. There's gtest. And then we come down to what's actually important here. And that is like some global compile flags on some linker flags here. And then here we have an array of binaries. And these are the things that TerraBuild can actually build. So first we have a library here, which has got some source file, give it a name. It's got some compiler flags, and it's got some export and include directories, and it's put in some destination. Also, we have an executable here, same story. It's got some sources and some compiler flags. And in the end, we have obviously a test, as you should also always have. So that's essentially how TerraBuild works. Let's just try to... We should be able... The way it works is... TerraBuild, and if we want to build, let's say, lib hello world, you just run TerraBuild and say which binary it is you want to build. It finds all the dependencies, says a lot of text, and it has built now the lib hello world library. And the same thing goes for this executable here. So that's just a very, very quick introduction to TerraBuild. So what we'll try to do now is to integrate this build system into VSCode. So we have our extension here, and let's just run it. I think it's easier to show you kind of what is possible fairly quickly. We need to open our example project, TerraBuild. Sample project. So now we're running our new extension, which has support for this TerraBuild build system. You see we have a little status icon here saying, oh, we detected a TerraBuild JSON file and we will build lib hello world. Another thing is we have this little action button here, and this gives you a list of all the binaries that you can build. And this is a GUI element. It's a tree view. Actually, a tree view is quite flexible in showing all kinds of different data. In this case, it's very simple because it's just a completely flat tree view. And I'm just going to quickly show you how that is made. So in our extension here, you define a tree data provider. And the tree data provider has got a function called getChildren, which in essence returns an array of tree data items. And how we populate it is that first we read the JSON file, then we parse it, so we find what are all the binaries that are possible to build, and then we just map from this binary to some strings essentially, which becomes all of these tree items. And we've got some logic here to say, okay, if it's a selected binary, we add a little cross next to it. You can make something that looks a bit nicer, but this works fine as well. So doing tree views, I'm not going to dive too much into it. Again, there's plenty of documentation, and ChatGPT will be happy to help you with doing this. I'm just showing you how quickly it is. If you look at the code for doing this tree view, you see it's 50 lines of code. So it's quite simple to do. So what you can do now is, let's say we selected lib hello world. We have done the same as we had before. We have a task here, which is our build task. And now we can just call TerraBuild. As you saw from the command line we just executed, we just get what is the selected binary at the current time. Again, it's a command, so that will return whatever we selected in this one. So we can try to do that now. If I run this task, build selected TerraBuild binary, we should build lib hello world. So you can see we spawned a console here, which just executes this command, Python TerraBuild lib hello world. So fairly simple. We can try to say, okay, we actually want to build hello world here, run task, build selected TerraBuild binary. And again, we build the hello world, and TerraBuild obviously knows dependencies, so it's building lib hello world again. And after that, it builds hello world. Yeah, so that's an integration with your IDE with this brand new TerraBuild system. Next thing, we also want debugging, obviously, and again, works in pretty much the same way as we saw it just before. We just get the selected binary path, we get the selected binary idea for the current working directory, and we get the shared object library paths also from the TerraBuild binary here, or sorry, the TerraBuild extension here. But because we know TerraBuild a bit better than what we had before, we don't need to search for these shared objects because we know where they're going to be located. So we can actually, let's just look in the extension here how we find the shared object library paths. So here there's no searching for files because we have this TerraBuild config, and we can get the dependency here, and we just add that folder to the list of dependencies, and we can print out what is the shared object library paths, and we return that. So a bit more clever than previously where we just brute forced it, but that's because here we have the information. Let's just see if this works. We should be able to select hello world, select it, and we should be able to run a debugger. Let's just make sure that we have, this is lib hello world. Let's just put a breakpoint there, and a breakpoint here. And let's try to see, we have this TerraBuild launch current binary. We run it, and we should hopefully, yes, we hit our breakpoint because we did resolve the right shared object. And we can also go into the library here, and all breakpoints are resolved. So that's pretty nice. Yes. Okay. As you can see, also you can do some more nicer things here. We actually have some small buttons next to these ones, which makes it even easier. You can just press build here and it will build that one, and here we'll build this one. And again, also we can launch the debugger directly from here. Let's just debug this one. Wait, I think actually it needs to select first and then debug. Yeah, there we go. I had limited time to do this code, so we'll have to do with this. But again, the debugger is running. So at least we have some rudimentary integration of this TerraBuild build system into VSCode with a fairly limited amount of code written. How long is this extension? 130 lines of code. There's a parser for the TerraBuild thing. 86 tree data provider was like 50 lines of code. So it's not a huge thing to integrate these things. It's kind of the takeaway from this, and it's fairly simple to do actually. Yeah. So let's get back to the presentation here. I think that's actually kind of it for now. It is very much a crash course. It's kind of just to try to get your head into, maybe I could use this for my custom tools. Don't be scared. It's very simple to do. It's very easy. So yeah, just try it and see if it's something that can help in improving your developer workflow. So last but not least, just closing remarks here. Writing extensions for VS Code, it's easy and it's also fun. It must be said that I have only tried writing extensions for VS Code. There might be other editors that are just as easy and fun to write extensions for. I haven't tried that many other IDEs. I've tried a bit of Eclipse, some Visual Studio, but I've never really had the need to extend them like I've done with VS Code, and maybe I also haven't found it as easy as I have with VS Code. Essentially, when I'm doing my programming now, I almost always run VS Code in this extension development host because I keep developing my tools all the time. I'm also happy to hear that Eclipse Theia IDE is actually compatible with VS Code extensions. So the ones of you that are not entirely happy with VS Code and all telemetry and whatever there is, Eclipse Theia can actually just load in your VS Code extensions. And I tried with a fairly reasonably advanced extension that I made myself to load it into Eclipse Theia, and it seemed to be working with no problems. So that's very nice. I hope that all IDE developers will try to provide the same amount of documentation and ease of use as the VS Code developers has, and also these examples that you can find in the GitHub repository. It really helped getting started with writing these extensions, and I think that's kind of what have made VS Code as popular as it is. It is all of these extensions. And last thing, something I dream a bit about would be very nice is if we could have some common extension API for all the different editors, so that you write an extension for one editor and it can work on a big handful, because developers sometimes are not too happy that you force a specific editor down on them, especially maybe VS Code. So that's why I was happy that Eclipse Theia can actually be used as an alternative. But if there could be some kind of common extension API for many different editors, that would just be great. I don't know how far we are with that. But that was the closing remarks. I don't have anything else. I just want to say thank you very much to everybody. And that's it. Thank you.
Thank you very much. That was a very interesting talk. Actually, we have a little bit of time for questions, and I have one question. So once you've built your extension, how do you distribute
it? Yes, if there is nothing that's like no proprietary things, it's very easy to put in the VS Code marketplace, but that's probably not an option for most people. So there is well documented how you can package all of this into a VSCE file. And that you can just, well, maybe I can even show it. It is fairly simple. Let's see if I can do it real quick. But there is something called a VSCE file. And from your extensions, am I still sharing? Yeah. From your extensions here, you could click on this one and say install from VSIX. And that is one way of distributing. It's not automated as much. You can get some private marketplaces. That's something I actually skipped from the presentation right now because of time constraints. One issue with extensions from the VSCode marketplace is that there's a bit of a security concern there actually, because it's very easy to publish extensions and it's very easy to download extensions, and you don't always know what you're going to get. So one nice thing would be to have like a private marketplace inside your intranet where you get all your extensions from there. There is support for it, not officially from Microsoft. Eclipse Theia has got it, but Microsoft, you do need to do a bit of a hack to get that to work, to have some nice distribution. There's also some extensions that actually work as private marketplaces. So there's a few different options there. But otherwise, yeah, you need to tell your developers, here's the newest version, go and download it. So still a bit hand carry with the distribution of it.
And the TypeScript, is that compiled, or is basically
it's transpiled actually. So these TS files get compiled into JavaScript files here. Yeah, you can see they look somewhat the same, but yeah, they essentially get transpiled into this. You can see some of the code is quite similar, and some of it is not quite. But it's quite interesting technology, quite like. And then there's a map here that maps from the JavaScript to the TypeScript, so that your debugger knows what maps to what. So yeah, that's yeah.
But
like some of the stuff we also have in C++.
Runs in those JavaScript files, and those JavaScript files are not like further than when you ship the extension.
No, an extension is essentially just, I think it's almost just this out directory packaged down together with the package.json. Yeah. It's just a zip file. You can actually, if you can download from the VSCode marketplace, you can download all the extensions, you can unzip them, and there you see all the JavaScript code and all of that. But sometimes it's like when they bundle it, they make it a bit smaller, and it's not really readable at all. But yeah, that's the way it works.
Okay. Thank you very much.
Welcome.